Hello everyone, today I'm going to deliver another lecture on influence line of beam using Müller-Breslau's principle. And influence line of the beam, I will try to example of reaction of influence line of the beam, example of shear influence line of the beam, and example of the moment shear lines of the beam. Before I'm going to do perform the example, I'm just giving what is the Müller-Breslau's principle. So let's go. Here is the Müller-Breslau. If the coordinate of the influence line, this ordinate, that means x, y, z, x, y, z, and any beam or any frame, influence of any force, which is a reaction, shear force, and bending moment of any structure are equal to those of deflected shape, so it will be yeah, obtained by removing restraint. Restraint means the support and corresponding that the element from the structure, introducing in place of the corresponding unit deformation into modifier of the structure. Okay, so therefore the unit deflection of support used to the influence of the line of support reaction after removing the support. So after removing support, one unit is upward, then it will be like this. And unit discontinuity section use the influence line of the shear force after inserting sectional cut. So we have been cutting sectional cut, and it goes downward and it will be going upward. While unit rotation, it will be rotation use influence of the bending moment. So we will taking after the inserting internal hinge. So we are inserting internal hinge and taking the rotation is here. So it will be like this. So let's see how we have calculated. So we have been seen here. A figure is given here. For the beam are shown below. The influence line halfway. So reaction we have to calculate the reaction first. RA, RC. So RA and RC. At first I am taking the RA. It will be upward in one unit. What will be? It will be as we know, the support will be must be 0. So that's why it will be takes like this, and it will be takes like. So if we know if the two support is acting consecutively, then it will like as a fixed support. So that's why this two support is founding here. So it will be like the fixed support. It will be acting as fixed support. Okay. So RC, now we are doing the reaction is RC. Taking another here. So moment is RC. So we are taking in upward. Why we are taking upward one unit? Because we have been seeing here the support reaction after removing the support. So this is the principle. That's why we are taking here. So we are taking 1 unit to act. So what will be happen? The element will be goes acting like this, and it will be goes here as the whole are the one element, and another is going there. So it will be one element and it will be one element. So two element. So it will be like this. Okay. Now another we can see another example which is we have been seen. Okay, I'm not changing color. BB. Why is BB? This is the BB. So we have to cutting here. We're taking. We're just cutting this section here. After inserting this, and it will be going downward, and it will be going upward. As we have been seeing here, it will be going downward. Another is upward. So if it going downward, it will be acting like this, and after the upward, it will be acting like this, and it will be go there. So this will be for BB. Okay, so we've been seeing the BB is acting is downward, and it is going upward and going downward, and for hinge support it will allow the rotation is here. So there is no influence line there because this support consecutive support is acting as a fixed support. So BCL, L mean left. So let's see how we'll calculate BCF. left. So we are just putting here in left section and cutting here and down, taking here this element is going down and another this element is going upward, so it will be acting like this. So there is we have been seeing this is the minor, that's why it will be acting this way and this way. Okay, I'm just erasing here. Okay, it will be acting this way. Why? Because we are inserting in the left section, that's why this portion will be downward, and this portion if we want to upward, then it will be slightly gone there and it will be here. So that's why you have been seeing this portion is gone downward. After removing here, this this element will be going acting like in left portion. Variable right portion, if we inserting if we cutting here in right portion, so if we want to downward in this element, there will be no such as deflection, as we have been seeing. If the two support is consecutively acting, that will be fixed, so that's why it will be not acting. And the right portion we have been seeing this element, it will be totally upward and then go acting like this way. So in this way it is going upward and acting like this way. So BE, we have been seeing BE, here is a BE, it will be going downward and it will be just erasing here. Left portion is going downward and right portion will be going upward and acting like this. So MB, we've been seeing MB, we are inserting hinge, as we know the bending moment after inserting an internal hinge. So after internal hinge, we are taking the rotation here. So we are taking the rotation, so it will be acting this, and for rotation it will be acting this and like this way. I'm just erasing another. Okay, so it will be acting like this. This is our acting like this way. So MC, if we want to draw the MC moment is here. So as the support, we have inserting and hinge in support, so the support will be not going in upward. So there will no rotation will be allowed. If rotation in left side, then no change. If rotation in right side, then we can see the element will go down in this way and it will be acting like this. It will be acting like this. It is an exceptional, as if if we want to moment in support, then support will be not allowed in rotation. So ME, and similarly if we calculate in ME, here is the ME. So if we go is ME, then it will be allow rotation is in left side and right side also. So it will be acting this way and acting this way. Okay, this way. So another, we can see last one, the shown for the beam shown below, draw the influence line of MA, MB, MD, MC, MF. So all of the moment is here. So we just using moment, using the using while the unit rotation is used. So we will unit rotation used for an influence line of bending moment after inserting the internal hinge. Okay, so let's see how we will calculate MA. This is the portion of MA. So if we insert the internal hinge, so there will be no rotation is allowed, rather than it will be deflected like this way. It will be deflect this way, and it will be go down and here. So as it is the ruler support, that will be must be 0. So these are the MA, influence line of MA. Okay, so let's see another one, which is MB. So this is the MB. If we inserting internal hinge, if we rotating in left side, so no change will be appeared, and it will appeared if we apply the rotation in rightward, then it will be changed like this and this. Okay, so these are the RMB. It will be acting like this way. Okay. So what will be value of the moment in MA? We've been seeing the distance. All the distance will be in the moment of value of the moment is 15 and 15, 13 and 20 is 50. So if we rotation here for D, so we can see the distance 20 and 20 and 15, it will be 35. Okay, so from similar triangle we will get this value also. It will also. So now see another graph is MD. There is if it is internal, already there is an internal hinge. So if you give it the rotation, so there will be no change in the frame. So there will be 0 MD. So another on ME, we can see ME. If we take the internal hinge here and just erasing here, then what will be happen? So there is no change in left side, that is the fixed support is here. And right side it will be changed. We have been seen this way, ME, sorry, this way will be changed, and the left side it will be not changed as this is the fixed support, so this element will be not changed, but D2 element will be changed as the rotation will be allowed up to hinge support. So it will be like this. It will be acting like this. Okay, I will get this below. So AB into A plus B. AB means left section. This is the distance of A, which is 15, and right section is B, which is 16. This is the A, and this is the B. So 15 into 16 and 15 plus 16, it will be 7.7. And in this way we will calculate the similar triangle. We will use this. So now last one, AMF. I will calculate AMF. As we know, this is the movement at the support. So rotation does not allow. So if you use internal hinge, so if you apply the rotation in left side, there will be no change as the fixed support is here. On the other hand, it will, in the rotation right side, it will be acting, it will be deflect like this. Okay, it will be deflected. I will get the value. It is the distance. The distance is will be there. So I hope that you can understand. Thank you, everyone. If you have any question, then let me know. I will try to convince your answer. Thank you.